Okay, fifth graders, today is October 16th, and we are doing Module 2, Lesson 8, continuing on from what we learned yesterday about area models and standard algorithm. As you can tell, you have a substitute today, so you need to please take responsibility to pause this video frequently as you're watching it to make sure you're keeping up with your math notes and ensuring that you are doing enough math thinking and following along so that you can get the most possible out of this lesson. Today in Module 2, Lesson 8, our learning goal says I can use the standard algorithm to multiply multi-digit whole numbers and use estimation to check if my answer is reasonable. We've been working really hard over the past couple weeks using area models and seeing how those area models are related to the distributive property and how actually it's really just the same partial products and the same work that you're doing when you use the standard algorithm. So today we're going to be focusing mostly on the standard algorithm, but I really want to emphasize this part. In math, it's always really important to use estimation to see if your answer is reasonable, to see if it is in the right zone. Because a lot of times when we're careless, we might not be paying enough attention and we come up with an answer that's completely ridiculous, that's not even possible. Okay, so today I'm going to show you how we can use estimation first to make sure our answer is reasonable. You should have solved the problem of the day together with your substitute, but if not, please pause the video to collect your thoughts, making sure you write down what the question's asking and the important information before going on to see the answer and checking your work. Okay, the directions tell us to estimate the product first, and then to solve using the standard algorithm, and then we use our estimate to see if our answer is reasonable. Okay, so if I want to estimate, I know that 314, the first factor, is pretty close to 300. And 236 is pretty close to 200. Okay, so that's easier for me to do in my head because I know that 3 times 2 is 6. And then there are 4 factors of 0. I mean, not factors of 0, 4 factors of 10. So we show that by using the zeros. Okay, so my answer should be somewhere pretty close to 60,000. Okay, now let's set it up so that I can multiply using the standard algorithm. Okay, 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. Now I add a placeholder 0 because our next digit that we are multiplying by is in the tens place. We're not really multiplying by 3, we're multiplying by 30. 3 times 12 is 12. 3 times 4 is 12, sorry. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. Now I'm moving on to the hundreds place. So I'm going to add 2 placeholder zeros for my next partial product because we're not really multiplying by 2, we're multiplying by 200. So we're automatically going to have 2 factors of 10 in our answer. 2 times 4 is 8, 2 times 1 is 2, 2 times 3 is 6. Now I have 3 partial products. As we noticed last week, because my bottom factor has 3 digits, we're going to have 3 partial products. If I add up all my partial products, I get 9, 13, 21, let me write it neater. Okay, 10, 12, 14, 74,104. Let's go back and look at our estimate. Is it pretty close? Well, you know, it's not that close, to be honest with you, right? 60,000 is pretty far away from 74,000. 74,000 is quite a bit more than 60,000. Let's see why. When I rounded my 314 to 300, I made it smaller. I also made this smaller when I rounded it to 200. So it makes sense that my estimate would be quite a bit smaller than my actual product. I do feel like it is reasonable though, because it has the right number of place value digits and it's not that far off. So yes, I'm going to say that based on my estimate, my answer is reasonable. Pause your video to make sure you're taking good math notes, and when you're ready, go ahead and resume and play it. We're going to do the same thing here. We're going to start by estimating to see if our answer is reasonable. Okay, I know that 1,882 is pretty close to 2,000. Now, keep in mind that I'm rounding it up this time, so I think that my estimate may end up being bigger than the actual answer. 296 is also really close to 300. Notice how I'm making my rounding, my estimating, I'm rounding up. So my estimation product, what I'm doing right now, should end up being bigger than my actual product. 2 times 3 is 6. I have 5 factors of 10 this time. So I think my answer is going to be around 600,000, but I think it's going to be lower than 600,000 because the actual numbers are lower than my rounded estimates. Now let me do my standard algorithm. When I set it up this way, because my bottom factor 296 has 3 digits, I know that there will be 3 partial products. Okay, to be honest with you, fifth graders, I had to redo this calculation several times because the digits it's not hard, but because there are more digits, I was making careless mistakes a lot. So make sure that you take the time to really be careful and line up all your place values so that you don't make mistakes. Okay? My final answer is 557,072. That is quite a bit less than my estimate, but that's what I expected. Because remember, I rounded all my factors up. So my rounded product should be larger than my actual product. So based on my estimation, my answer seems reasonable. Okay, same thing here. I'm going to estimate. I'm going to say that 4,902 is pretty close to 5,000. And 408 is pretty close to 400. 5 times 4 is 20. And then I have 5 additional factors of 10. 3, 4, 5. So I think my estimate says that my real answer will be somewhere near 2,000. Go ahead and pause the video and do your standard algorithm. Be super careful because, as I said, it's easy to make silly mistakes. Then, when you're done, resume to check your answer against mine. Okay, I've now done 4,902 times 8. I noticed that normally I would move into the tens place, but that's 0. So I'm going to skip it. I'm going to move into the hundreds place because 0 has no value, right? So there's no tens. It says that there's 0 tens, but there are 4 hundreds. Be careful. It's very easy for fifth graders or for anyone multiplying really to just put one placeholder 0 because this is my second partial product. However, because we're working in the hundreds, make sure that you put 2 place value zeros because, again, we're working in the hundreds. Now I do 4 times 2, which is 8. 4 times 0, which is 0. This is another 0 that's very easy for people to remember. For people to forget. Okay, so be careful. 4 times 9 is 36. We're going to regroup the 30. 4 times 4 is 16, plus 3 is 19. Now, I only have 2 partial products at the bottom, even though this has 3 digits. The reason for that is because the tens digit, 0, has no value, so there really are no tens. It's just the placeholder. Now I'm going to add up my partial products. It's a lot of regrouping here to get a final answer of 2,016,000. And as expected, based on my estimate, that is in the right range, so I feel good about my final answer. Now, fifth graders, I included this problem on purpose because those zeros were really tricky. I want you to write using words why the 0 circled in red were tricky to think about, as well as why the zeros circled in green were tricky to think about. Pause the video right now and write down why those zeros were tricky. Okay, today I would like you to do these following problems in your problem set, then turn in your exit ticket. When you're done with the exit ticket, you can work on Zern. If you don't have enough time to do Zern today in class, you will of course finish Zern for homework as well as the rest of the problem set. Thank you.